Okay, boys and girls, let's get this started. Second lecture, welcome. So by now a couple of things should have happened. One, you should be sold on the idea that we need to become masters of areas. Second, you should be sold on the idea that we need to become masters of slopes. And third, you should be sold on the idea that our area skills and slope skills are weak. They're childlike. We need to improve our skills to find areas and slopes for grown-ups. That's what's happened so far. And so far in the history, the way it happened, it's been about 2,000 or 3,000 years. We gotten that far, I'd say, from 4,000 BC to about 500 BC or 1,000 BC. That's how much it has taken just to come up with these three ideas. And now we come to the height of the great Greek Empire with Archimedes, and some new ideas are brewing up, ideas to find exactly this area. And as it proved throughout history, what was required was not some little tiny idea. A big idea was required, and not some shy idea. A bold, big, and brilliant idea. That's what ended up being. Nothing short of that is what was required to conquer and triumph over the great question of areas for grown-ups. So that's what we got to do today. I told you in calculus there's only 2 or 3 beautiful ideas, and the rest of it is grunt work. Today we will see those 2 or 3 beautiful ideas. We'll get to see a little tiny taste of them and make our way through them until we dominate them. Anyway, so here's what happened. I'd say this puts us at around, I don't know, 3,000 years ago. Okay, so 3,000 years ago, I'm going to tell you the story of the way it happened. Okay, 3,000 years ago, so this is the way it happened. They said, you know what? We have a great idea to conquer this problem. We will cut this area for grown-ups, and we will cut it into little pieces that are areas for little kids. We will cut it into a little rectangle like that, and we'll make another little rectangle like that, another little rectangle like that, another little rectangle like that. Aha! We take the original problem for grown-ups and cut it up into little chunks, each of which we can do because these are all rectangles, base times height. And you go on and you calculate these like an ant, insect thinking. Calculate that area, calculate that area, calculate that area. There you go. This is the proposed solution. I'd say maybe 3,000 BC. Okay, that's how much progress we've made since humans, when humans had a lot of hair in their hands. What do you think about that? Big, bold? Not that big, not that bold, not that brilliant. Because why? Because you got a whole bunch of errors. You got error there, error there, error there. You got an error party going on here. That's no good. But that didn't stop the human spirit. The human spirit will never be dominated. Perseverance in abundance is what we have. Humans persevered, and guess what they did? It only took them a little bit of time, but maybe 1,000 years. By whoa. Where am I? Right here. By 2000 BC, it only took them 1,000 years, and they had come up with a better idea. Instead of cutting it up into 4 pieces, they decided to cut up all these areas not into 4 pieces, but guess how many pieces? Into 5 pieces. Can you believe it? They cut it up into 5 pieces. They thought they had the audacity that they would take this and cut it up into 5 pieces. 1, 2, 3, 4, 5 instead of 4. And now look what happened. You still got an error party going on here. Error, but the error is not as bad as it was before. It's getting a little better. And it's only taking people... What is going on here? It's only taking people about 1,000 years to make that progress. So from 3,000 BC, they were cutting things up into 4 pieces. 1,000 years went by, and they had the brilliant idea that they would cut it up into 5 pieces, and therefore reduce the error. Still adding them up like insects, but it was an improvement. And then 1,000 more years went by, and guess what happened? They got the brilliant idea that they weren't going to cut it up into 5 pieces because that gave too much error. They were going to step it up and cut it up into you guessed it, 10 pieces. And that was a brilliant idea. Whoa, 10 pieces. Look at that now. The error is almost none. Well, depends on how rigorous you want to be, but that was kind of better. I wouldn't say it's big, bold, and bright, but it's kind of headed in the right direction. And it's only taken people, say, I don't know, about another 1,000 years. Maybe this would be like the year 800 BC. People are starting to get smart, and they're starting to think, hey, if we cut it up into more pieces, the error gets smaller. When the error gets smaller, the ideas get brighter and bigger. Ain't that something, huh? But wait, there's more. Guess what happened in the next few hundred years? It only took humans another 300 years. And at the height of the Greek Empire, I'm just going to estimate here, okay? 400 BC. You got people like Plato, Socrates, Archimedes. Everybody's having a think fest. They're bringing thinking back. They love to think about philosophy, about the republic, about the important questions about life, and of course about areas under the curve. And Archimedes almost gets it done. He has the audacity, the boldness to say, you know what? These other people 500 years ago or whatever, they were crazy. They were cutting it up into 10 pieces. I'm going to step it up a notch. I'm going to go not 10 pieces. I'm going to go for, guess how many pieces? 20. No. He's starting to become really bold. Really bold. Not 20, not 30, not 40. He tried to cut it up into as many pieces as he could. That is starting to have the makings of something bold. Why? Because after you cut up into many little pieces and you make these little rectangles, you got to go on and add them all one by one. And that takes audacity and perseverance, which the human spirit has proved over and over again that it has plenty of that. Plenty of audacity, plenty of perseverance. And then he he flirted with the idea. Yeah, this requires a drum roll. This requires a drum roll. This is the big bold and I wait. Wow. Applause. Drum roll. He flirted with the idea. Let's do that again. I gotta practice that for my lectures. Can't do that in class, huh? Told you. He flirted with the idea of not, this is 400 BC Archimedes, he flirted with the idea, he called this his method of exhaustion, which means he did it till he got tired. Method of exhaustion. He flirted with the idea of doing it till he got tired, till he could do it no more. Not 1,000 times. No, he could go on for more. He had more stamina than that. Not 1 million, not 10 million, not a million, but he flirted with the idea of he flirted with the idea of oh no, here it comes. He flirted with the idea of infinite many pieces there, infinite. And that concept that's the concept, that's the big, bold, and brilliant idea, to think that you could cut this up into infinite many pieces that are infinitely small. Think about how big would each one have to be if there's infinite many of them. The little area, that little rascal would have to be pretty close to zero, because if it was anything bigger than zero, you could cut it some more, and if it was anything bigger than zero, you'd probably have errors up here. So you want to cut it up some more until you get really close to zero, and then cut it some more. Try to get your head around that. And then you'd have to add that one, which is approximately 0, plus that one, which is approximately 0, plus that one, which is approximately 0. You'd have to add things that are approximately 0. How many times? Approximately infinite many times. Boys and girls, that's no feat for mortals. mortals had never ever in their existence done anything like this. 0 plus 0 plus 0 plus 0 plus 0, or something close to that infinite many times. This is equivalent to saying something so out of this world, such as infinity times 0, that it makes your head spin. It put people in jail. When at first, when they were talking about this, people were put in jail. They were kicked out of the Roman Catholic Church. Everything, the whole world was breaking down. They couldn't handle it. They weren't ready for such a revolutionary idea as taking something infinitely small, not just one thing, infinitely many of them, and then having the audacity to think that you can add them all up. Well, we did it. It didn't happen for Archimedes 400 BC, but throughout the history of humans, this is their Ninth Symphony, it was like a relay of intellectual giants chipping away, chipping away, chipping away, until the most elegant solution came about in the 17th century by two people, a guy named Newton and Leibniz, and they told people exactly how to do it with great style and elegance like you've never seen before. That's the kind of idea that should be on the short list of Ninth Symphonies for humans. By the way, I'm still waiting for that. Put that on the comments here. I want to see people's list of Ninth Symphonies. What you think is humans' greatest creation? One of my students said last time on lecture, Wright brothers. Oh my goodness, what a good point. Imagine the Wright brothers. To have the audacity to think you can fly like a bird. I love being human. That's why I love being human so much, because we've got this heritage of indomitable spirit. They tell us things can't be done, and we do it anyways. Michael Jordan has his cool commercial. He says, "Tell me I'm too old. Tell me I'm too slow. Challenge me. Disrespect me. I want you to." I love it. Anyways, this has to be one of the most bold and most brilliant and biggest ideas. To think that we can do it. Not just to think that we can do it, but actually when we got the job done. Not we, but we collectively. But Isaac Newton and Leibniz around the same time in the 17th century. If you ask Newton, he'll tell to you himself, "If I have seen further than most men have, it's because I've stood on the shoulders of giants." He's talking about all the progress that's been happening for the last 1500 years before him. Anyways, that's got to be it. That's got to be one of them. The big, bold, and brilliant idea to think that you can slice up an area into infinite many pieces, each which is very, very, very close to 0, and have the audacity to think that we can add them all up. And not just add them all up, but add them all up with style and elegance. Are we out of focus here? Let's see if I can focus. No, we're good. All right. Anyways, that's one. Let me show you a different look at the brilliant idea. We've already sold you on the idea that you got to become good at slopes, right? So these slopes are for grown-ups because they're so hard because their belly touches in one point. I try to zoom in there, and you've only got one point here. Here's the brilliant idea, another brilliant idea, along the same flavor as the last one, that changed the course of history. People had the audacity to think about taking 2 points and making them closer and closer to each other and try to compute the slope and see where it goes. But this is, keep in mind, this is zoomed in like a gazillion times. It's barely like a little dot there. You can't even see it. It's so zoomed in that the change in y is approximately 0 and the change in x is approximately 0. And what you're doing is you're computing a slope, which is something where it's approximately 0 divided by 0. Now, how many times in school have you been told never ever divide by 0? Imagine humans being told that throughout their life for 3,000 years, and then you got one oddball human saying, maybe I can do that. Yeah, maybe I can do that. After being told 3,000 years you can't divide by 0, and they do it anyways. This reminds me of like riding the bull. Imagine the first person who looked at a huge bull, the big horns and the puffing nose, and said, you know what, I think I want to ride that for 8 seconds. It's riding the bull, baby. Right here, divide by 0. When everybody tells you it can't be done. That's right. Well, we did it anyways, but it requires a whole new type of thinking. Again, people were put in jail for that. Talking about dividing by 0. People like Galileo. Let me see, where are we at now? So here's the second big and bold and brilliant idea, to think that we can divide a number that's really, really close to 0 by another number that's really, really close to 0. Let me show you why that's, try to show you how difficult that is. If you have the old kind of thinking, if this is a number that's close to 0, give me a number that's really, really close to 0. Say it's like 0.0000005. all over 0.0000001. This is a number that's really, really, really close to 0, and that's a number that's really, really, really close to 0. And when you divide them, you get 5. Whoa. So what was the problem? Why did they tell you you can't do it? I just did it. But wait, it gets more interesting than that. Suppose you have 0.000000015 divided by 0.0000003. No. 0.0000030. Whoa, now what? This is equal to 1/2. What? This is like a chameleon. A number divided by 0, a number close to 0 divided by another number close to 0. It could be anything. Isn't that crazy? It is like a totally different kind of arithmetic. Something that had never ever been done in the previous 1,000 years of existence of humans. No one had ever dared to do arithmetic like that. It really required, these ideas required a revolutionary way of looking at arithmetic, with new numbers, new way of the whole thing the whole book had to be thrown away and almost reinvented, because these ideas were not from the current world. They were way ahead of the game. So with that in mind, let me pause this for a second, get my thoughts together. Okay, I'm ready to continue. So this sort of idea of counting, things like dividing by 0, and things like cutting things up into infinitely many pieces that are infinitely small, that requires a whole new paradigm, a whole new way of looking at life, a whole new way of looking at numbers. Consider the way the numbers were before calculus. This is the kind of numbers we have, and this is the kind of arithmetic that people could do. You have numbers like 3. My 3-year-old knows that. Ask him, how old is he? 3. You have things like 5. My 5-year-old knows that. Ask him, how old is she? She's 5. Etc., etc. 11, 9, those are the age of my kids. 12, 13, 17, those are the age of my kids. I'm just kidding. I don't have that many. Anyways, these numbers are really easy. You could count with them. You could add by them. Look, 3 times 5. Look how easy I do it. 3 times 5, 15. Look at that. There's plenty more where that came from. 11 plus 11, that's 22. Arithmetic here, if you think about this bucket as the bucket of numbers with which your children play, it's pretty safe for them to play with all these numbers. They can do it. It's no problem. This is the bucket for children. It's like a bucket of toys for them. Pretty easy, huh? And you could use these numbers to count a lot of things. You could count, for example, you could count apples. Look at this. 1, 2, 3, 4, 5, 6, 7 apples. You see that? Told you. These numbers, you can count a lot of things. If you want to get a little funny, you can count clowns. 1 clown, 2 clowns, 3 clowns. See, you can count with these numbers. But you know what you can't do? One thing that you cannot do with these numbers is divide something 0 by 0. That's not going to happen. This bucket doesn't have the right toys to do that. It'll explode if you try to do something like that. The other thing it can't do is the other thing it can't do is it simply can't do stuff like this. This kind of arithmetic, 0 times infinity, it's not going to happen with numbers from this bucket. This bucket of toys just doesn't have the right equipment to do stuff like this. This is for grown-ups. What it requires is I remember when I was a kid, I remember in Mexico, we'd have parties and there'd be all kinds of grown-ups there, and all kinds of grown-ups there, and they always had this pot or this big bucket of something to drink, and they always had several of them, and one of them they said, hey, kids can't drink that bucket, you can't drink from it because that's for grown-ups. What they had done is they had poured something extra in there. They had poured a little something interesting in there, and it made the buckets not for kids, it made it for grown-ups. Of course they were putting like alcohol or spirits or something in there, and it made it the bucket for grown-up drinks. That's the kind of stuff we have to do with our numbers. These numbers right here, that's arithmetic for kids. But if you take that bucket and you add a little something extra, say you add the number like 0, and you pour it in there, and say you add the number like infinity and you pour it in there, oh, now you got something interesting. Now you've got a very interesting bucket. Much more interesting, because now you're gonna have to do things like this: infinity times 0. What is infinity times 0? That's a bucket for grown-ups. The kids shouldn't be drinking out of this. You're gonna have to do things like 0 divided by 0. That, my friends, that was the biggest boulder. That's got to be on the short list of 9th symphonies for humans. All right, playing around with this bucket. Now we've done a lot of stuff today, so I don't want to do too much. Let me try to wrap it up this way. Maybe we can do just one little arithmetic. You can think about infinity as a large number. What would happen if you take infinity? Let's see how good we are with the big bucket, big boys bucket or big girls bucket. What's infinity plus 5? You take a huge number and you add 5 to it. What would you think you'd get? Well, another huge number. So infinity plus infinity equals infinity. No, sorry, infinity plus 5 equals infinity. Interesting, huh? That wasn't so bad. Yeah, actually some of the things in here, they're not that bad. They're actually, even kids could do it. Infinity plus 152. That's infinity. See? Some of them are actually really easy. You don't need much more than intuition and you can figure it out. But some of them get a lot more interesting, such as infinity minus infinity. If you have a huge number and you subtract another huge number, what do you get? The trouble is that not all infinities are created equal. See, this infinity over here is 5 more than that infinity. They're not really created equal. If I took their difference, it'd be 5. If I took the difference for these infinities, they're different kinds of infinities, it'd be 152. So this is, whoa, I'm telling you, kids, don't drink from this. This is not for kids. You need a real good calculus course to sort all this out and see the great ideas that have been we've inherited from our ancestors. 4,500 years of brilliant ideas. Let me try to summarize it for you, because we've done a lot and it's got to look good in perspective. You got to have the good big picture, otherwise it's meaningless. Doesn't mean anything if you can actually carry out computations and you have no idea what the hell's going on. Let's put it all in perspective. We established the ubiquity of areas, how they're meaningful, and it's exactly the same question as slopes. Check. We established that we want to figure that out for more interesting areas, not just squares or plain lines. Check. That require big, bold, and brilliant ideas. We're going to slice this up into infinite many little pieces, infinite many that are infinitely small. Each one is close to 0, and add them all up. That's much harder said than done. And we're going to take points that are infinitely close, and we're going to be doing things like 0 over 0, roughly speaking. And here we're going to be doing things like infinity times 0, roughly speaking. Those are big ideas, bold ideas, and they in turn require for us to look at arithmetic in a whole different way. We have to add these numbers here, infinity and 0, that make the whole bucket tainted, not for kids. And that's where we're at for next time. Next time we will begin our study. We started, I gave you just a little tiny taste of arithmetic, but next time we really have to start with this new kind of arithmetic, drinking from the water for grown-ups. Wow, I think that might do it for today. I can hear the music. That means I that should do it for today. Peace. See you guys here next time.